Here we go. Today we're talking about something called a 2, 3, 4 tree. You notice it's missing a word in front of there that starts with a B. That word would be binary. We're no longer talking about a binary tree. We're taking a look at a new data type, an ADT, abstract data type, called a 2, 3, 4 tree. Well, what is a 2, 3, 4 tree? The key numbers are 3 and 4. Not sure about the 2, but what we have is a tree that's now going to have a node that looks like these down here, where instead of storing one item, or like the one assignment you did with binary trees where you were storing letters, we're going to be able to store multiple items. And in this case, in a 2, 3, 4 tree, as it's called, we're going to be able to store 3 items and have 4 pointers coming out of here. So instead of a binary tree storing one thing with a left and a right, we now, in this case, have a left, a semi-left, and we have a couple of combinations coming out of there where it can go. So we're looking at nodes that can hold up to 3 numbers, and we'll have 4 pointers coming out of it. All right, so when I get ready and talk about a 2, 3, 4 tree, I have an M node has M minus 1 data values and M pointers coming out of it, pointing to subtrees. Each node stores at most 3 data values. Each node leaf or each non-leaf node is a 2, 3, or 4 node. And all the leaves will be on the same level. It's kind of different, but once you see what's going on, you're going to see all the leaves will be on the same level, because as we fill this, which is what we're going to spend most of our time today, you'll see that I fill up top and then I work my way down, and when down gets full, I see if I can fill up top again, and I'll just keep splitting, growing, filling in this tree with values instead of just dropping down farther and farther and farther. If you take a look at this little binary search tree on the right, we have, I was able to store 1 value, but if I went to a height of 2 and had 2 levels, I was able to store 3 values. Then I start to grow pretty quick. Then I can add 4 more. I could store a total of 7 values and go and go and go. Well, if I take a look at this guy, on its first level, how many values can it store? 3. That's right, 3. On the next level, how many values can it store?
12.
12, right? And how'd you get that mathematically? Give me some math.
4 times 3.
4 times 3. Okay, how many would be on the next level? Well, out of this guy, there would be a 4 times 3, right? Out of this, just like up top, out of him came 4 times 3. So out of this one will come a 4 times 3. Out of this one, a 4 times 3. And this one, and this one. So how many 4 times 3 did I have? 4 of them. So now I'm looking at 4 squared times 3. Guess how many would be on the next level?
Cubed.
Yeah, 4 cubed times 3. So, all of a sudden, after the first level, I can store 3. After the next level, I could store 12, giving me a total of 15. Now I'm looking at 48, giving me a total of 63. What do you think the next number would be? My math geniuses? Sequences and series and all of that stuff in pre-calc. What would the nth one be? The nth row, how many total items could I store?
192 plus 63, right?
So here it would be, you're going 4 cubed plus 3 equals something, and then add it to 63. Yeah, I'm doing this. I'm doing this. 4 to the first power minus 1. 4 to the second power minus 1. 4 to the third power minus 1.
So 191.
So 4 to the fourth power, you say it's 191? This would be, if I said the nth one, it would be 4 to the n minus 1 power.
Seems right.
Yeah. Or 4 to the, what's the formula there? So if I'm at level 2, oh, I need a times 3 in there. I'm sorry, I'm missing something. 4 to the n minus 1 times 3 minus 1. Okay, so you could see where a bunch of math would come into play if needed so. All right, now let's get into figuring out how to do this. This is a new data type, and as all new data types go, we have, we need to be able to build it. We need to be to see if it's empty, to search it. How would I insert? How would I delete? Oi polloi. We're just going to work on constructing one. So I'm going to start out. Can you see my numbers, or your pictures over top of it, or what? Can you see the numbers?
Yeah.
Okay. First number, 53. Yeah, that's not so bad. I come up here and I simply put in a 53. If I need to search for it, my search time on these is great. I come in and, okay, 53. My next number is 27. All right, so that's going to change this guy a little bit. I'm going to have 27, 53, and nothing. My next number is 75. So I'm going to have 27, 53, and 75. Filled it up, still on the first level. Life is good. Billy has his beer goggles on. I'm going to erase some of these so I can keep track. Of course, I think I did them in pen or something. The next number after 75 is 25. 25, it says we can't fit. 25, so I still need to leave something up here in my root. So now that I get 25, I jump to a new level. But what I leave up here is 53. And I have 27 and 25 are going to go to the left. 75 is going to go to the right. So now I have 53. And I start thinking about my pointers coming out of here. Okay. Now, I'm looking at this and lots of different ways to do it. I don't like that. I like to think of it as 53 is there. Over here becomes a node with 25, 27, and blank. And here comes a node with 75. Not too bad. 5 values or 4 values stored, often looking pretty good. Next number I want to insert is 70. I come in. Now, I don't keep filling here because I have a new level. I'm going to keep filling this level. When this level is full, we'll see what happens. So now I have a 70. That's going to come into here and bump 75 over. I have 41. That's less than 53. That's going to slide in there really nice. So from a programming concept, once I get how this works, I need to be thinking about when I insert these, moving them to the right when they come in and so forth. But I want to keep them sorted numerically. I just put the 41 in. I now want to put the 38 in. 38 goes to the left of 53, but this node is full. So now I'm going to split this node. And like up here, I kept the middle. I'm going to keep the middle, which is 27. And when I keep it or give special attention to it, I'm not going to drop down because there's room up above. I'm going to send 27 up above. So now I'm going to get something that looks like I'm sending 27 up. So up top, I have 27, 53, and a blank. To the left of 27, I have my new number was 38, right? 38 wanted to get in that group and they wouldn't let it in. So to my left of 27, I still have 25. To my right of 27, I now have 38 and 41. To the right of 53, I still have my 70 and 75. And of course, this guy just keeps tagging along at null. All right, we just put in 38. Where will 16 go? Down here at 25? But I'm going to have to put it in order. Where will 59 go? Well, it's greater than 53, so it's going to go in this node. So 59, 70 gets moved over, 75 gets moved over. So again, my main goal here is if I get ready to search, I come in and looking for a number, 11. I come into this node. Is this 11? Nope, it's less than, go down this tree. Once I get in here, I look at the first number, up, it's 16. If it's less than, oh, it's null, not found. If it's greater than, I would move over. If it's less than, I would check the tree coming out. All right, we just added 16, added 59. I want to add 36. It's not less than 27. It's greater than, so it's going to come down into here. This is going to be 36. This is going to be 38. And this is going to be 41. I now want to add 73. What happens when I add 73? Well, it's greater than 53. It's going to try to come down to this group. What's going to happen to this group? Right? It blows up. 70 is the middle term. It's going to move up. To the left of 70 will be a 59. To the right of 70 will be the 73 and the 75. So now I have 27, 53, and 70. Over here I have 16, 25. Here I have 36, 38, 41. Here I have, let's see, I blew this guy up because I moved 70. So all I have is 59. And all the way out here, when I blew up 70, I was left with 73 and 75. Now, what happens, say, if I put a number in like, oh, I'm sorry, you can't see it. My apologies. So when I did this, 70 went up. To the left of 70 was a 59. To the right of 70 was a 73 and a 75. So if I now get a number less than 27, it'll go here. Between these two, it'll go here. But guess what happens if it goes here? I have to blow this up. I'm going to send 38 up. But when I send 38 up, it causes me to blow this up, which now 53 will be the only term, 27 and whatever else will go to the left, 70 will go to the right. If I have a number bigger than 53 and less than 70, it'll go in here. If I have a number greater than 70, it goes over to there.
So you don't go to the next level until all the spots are filled?
Well, not all
This
of
is-
them, but so this is filled and this is filled. Because these two are filled, if I tried to put one in here, it's going to blow this one up, which sends the value up. But if I move up a level and it's full, then I have to blow that up and create a new row. So
Okay.
let's just, I don't even know what my next number is. I have a whole bunch of numbers that I keep adding. 65 would go here. 65 would go down here. My next number was 60. 60 would come in here and move 65 over. So I'm getting kind of lucky so far. I then have a 46. Okay. So let's see what happens when we put in a 46. It's going to blow some stuff up. See what you get. Hang on 1 second. We want to put in a 46. Tell me what you get. I'm going to put in 46, which wants to go here, but it can't. Okay, so it sends 38 up. When 38 tries to go up, we have a problem. So now I'm going to have 53 by itself. What's to the left of 53? Well, 38 is trying to come up here. So to the left of 53 is going to be 27 and 38. To the right of 53, or to the right of 53 is going to be 70. Okay, that was just looking at those four numbers. Now to the left of 27 is going to be what was here before. Between 27 and 38 is going to be this 36. To the right of 38 will be the 41 and 46. So let me grab another piece of paper. So right now 53 is king of the hill. Okay, to the left of 53 is the 27 and the 38. To the right of 53 is the 70. Now I still have this. I need a big whiteboard. Even though 27 moved down, its left tree stayed. So over here to the left of 27 is still going to be the 16 and the 25. Between 27 and 38, the 38 went up. So what was between them was the 36. Greater than the 38 was, this is where my problem came in when I wanted to add the 46. So it's 41 and 46. Still have a null coming out of there. Here's my 70. Okay, to the left of 70, which I kind of ran out of room, is still going to be my 59, 60, and 65. And to the right of 70 is going to be my 73 and 75. And of course, you know, adding more values will be great. If I added a value here, if I added a value like 63, it would send 60 up, move 70 over. And so forth. I'd be willing to bet y'all want to try another one. All right, seeing it is one thing, doing it is another. I'm going to make up a list. 70, 17. Why is my camera all funky today? 70, 17, 5, 23, 31, 11, 48, 21, 19, 3, 6, just a couple more. 68, 75, 72. Make sure I don't have any repeats. Does anybody know where my pencil went? Found it. Uh-oh, somebody else showed up. Who's here? Alex, Peter, CJ, or Dev? Dev is here. Dev didn't want to tell me. Dev is here. All right, hopefully you're off and running. I should do this in pencil in case I mess up, but I think it's easier to see in pen. I put in the 70. Then I put in 17. It's going to move the 70 over. Then I put in 5. So after the first 3 moves, I should be at something that looks like that. Put in the 70, the 17, and the 5, and I get that. $23. 23 is going to blow it up. Leaves the middle turn. I guess you can see that. I try to put in 23. It's on the right side. So that means here I have a node with just 5 in. To the right, I have a node with the values greater than 17. 23, 70. $31 comes in and moves my 70. Move it on over. Rock it on over. The 11 is less than 17. So it's going to go to the left. It's actually going to slide right in there. It's greater than 5, found a spot to put it. .48 would love to go right there, but it can't. So it's going to blow it up. It's going to send the middle term up. So my up is now going to be 17 and 31. When I blew it up, the 31 left, but the 23 is going to be right here. To the right of the 31 should be my 48 and 70. Wonder what you would call these pointers instead of Prev and Next. P1, P2, P3, P4? Maybe. .48 is in. 21, I come in, it's not less than 17, it's here. Ah, I have to move 23 over. This is 21, this is now 23. .19, that's a pain in the butt. 19, 21, and 23 should now be in here. Looks pretty. For me. Three is going to go to the left of 17. It's going to come in here. It's going to rearrange this guy. This is a 3. This is a 5. And that's now an 11. Six wants to play. 6 comes in. It's less than 17. It goes to here. And it's like, oh no. Blow it up. I'm going to send the 5 up. Is there room? Yes. So I send the 5 up. And now I'm going to have 5, 17, and 31. When the 5 went up, what was left of 5? Just a 3. What was to the right of 5? It looks like the 6 and 11. Between 17 and 23, we still had a pointer to 19, 21, and 23. And to the right of 31, we had a 48 and a 70. Once again, how fast is search time? Wouldn't take long to search this list. The numbers I have left are 6, 68, 75, and 72. Uh-oh. Wait, I just put 6 in. 68. 68's not so bad, right? It's going to be greater than 31. It's going to go to here. It's going to go in this puppy right here and make him a 68. And it's going to move 70 over. My next number, 75. My next number is 75. Where's 75 going to try to go? Here. 75 wants in this group. It's too big, so I have to blow the 68 out. The 68 is going to try to go in this group, but when it's full, I had to, so 68 is now going to try to come up to here, and I'm going to blow it out. Leaves me with 17 as the only survivor. To the left of 17 is the 5. To the right of 17 is going to be the 68 and the 31 that were coming up. Right? The 31 was already there. 68 is trying to come up. So again, just breaking it down. If I tried to add 68 to this, 17 would stay, 5 would go to the left, 31 and 68 to the right. What was attached to 5? 3. What was between or greater than 5 would be 6 and 11. Of course, I'd have another pointer coming out, another pointer coming out. I have pointers coming out of here. I'd have pointers coming out of there. Less than the 31 was the 19, 21, and 23. Greater than the 31, but less than the 68 was just the 45 or 48. Greater than the 68, I got it right out here, 70 and 75. And again, I'd even have a pointer going to one more if needed. Got a little sloppy there on the end. I have one more number, 72. That would jump in there. Greater than 17, not less than 31, not greater than 31, greater than 68, and then nothing's there, so it would come down. Not easy to program. Not easy. But it's another unique data type, another unique way to look at numbers, another way to speed up searching. A 2, 3, 4 tree. Questions? Do you have it? Anybody want to speak?